All right, this is a video for our geometry class on constructions, particularly basic constructions, intro-level constructions. And when we talk about construction in geometry, we're not talking about building a structure out of wood or something like that. We're talking about creating a shape composed of points and lines, perhaps, using a particular set of tools. In geometry, those tools are a compass and a straight edge. All right. A compass is a device that makes circles, and a straight edge is a device that makes straight lines. The important rules to follow around constructions are that you never measure and you never estimate. Okay? Measuring and estimation have error associated with them, and we're trying to be pretty precise, pretty careful, almost as perfect as we can be to create these shapes. When we create a construction, say we're constructing an angle, I care less about did we get the angle to be the right size in terms of how many degrees it is. I care more about the idea of what that angle is, sort of that ideal angle that we're trying to create. So we're never measuring, we're never estimating. We're using a straight edge to connect what I'm saying is precise points, okay? So we're never trying to guess where the straight edge goes. We're really just trying to be very precise, connecting to particular points with a straight edge. And notice that I'm talking about a straight edge and not a ruler, okay? So we can use a ruler, but we're not going to be using the tick marks, the centimeters or the inches on the edge of that ruler to measure anything ever, okay? This is a super handy method for just creating figures in geometry, and again, without worrying about, how many centimeters long the segment is or how many degrees the angle is, just to try to create some ideal figures. For my note app, as I'm going through this, I have some animated GIFs that I think will help you show how to do these constructions, but I'll also try to use some particular notation as well. Since it's hard I'm not videoing myself using a compass and straight edge, we're just seeing what's showing up on the paper essentially. So when I'm using a compass, I'm actually not going to literally be using a compass on my iPad. I'm going to try to model what the compass would do. So I'll do my best to create it as neat as possible. But I will mark a colored X as the center, the sort of where the metal tip of the compass goes, and then an arc showing the actual arc that the compass draws. And for a straight edge, I'll just try to represent all straight edge lines as straight black lines. Okay, let's see how it goes. We'll do our best. So one task that you might want to try, or that you're going to be asked to do with a compass and straight edge, is to create congruent segments. So again, we're never allowed to measure. We're trying to create another segment that is exactly perfectly congruent to that initial black segment. Okay, so here we have a blue ray on which we're supposed to construct our new segment, but we want a new segment to be drawn somewhere else on the piece of paper that's identical in length to the black segment. And you might be thinking, how in the world can we do that? Because we're not allowed to measure anything. But what we can do, we can set our compass to a particular size based on what we're given, and then transfer that length over to a different location. So I could put the point of my compass right there. I could open my compass up to that length and even draw a little arc if I wanted to. And then keeping the compass the same setting, I could put the point over here and draw another arc over there. And then I have a congruent line segment. So if this is line segment AB, perhaps this might be line segment CD. We could use congruency tick marks to represent them as being congruent. And we could also say that line segment AB is congruent to line segment CD. Okay, and we never had to measure anything. We got an exact congruency. Next is to create congruent angles. I don't have an animation for this. I have a series of images over on the right that I want to try to take you through. So let's say, for example, that we have a given angle, and separately we have a ray. And our goal is to create a new angle on this ray that's congruent to the given angle. Okay, so what I just drew in a red dashed line is sort of our goal. going to delete a little bit of that away to clean up the image. So first you're going to take a compass on your given angle and draw a arc of a particular radius from the vertex. And then you're going to draw an equal arc of equal radius on where you want your new angle to go over on your given ray. And then what we're going to do is go back to our initial angle and use the compass setting set between these 2 points on the initial angle and the initial arc. Maintaining that setting, we bring the compass over to our new angle and copy that arc. And then we have 2 points that we can connect, this point S and this intersection point here. Let's do it. So first we are going to set our compass on our initial angle, set the point, and draw an arc. Keeping the compass at the same setting, we go to where we want our new angle to be, and we draw the same arc, an arc of the same radius. Then we go back to our initial angle, and we put the point of the compass at one of those intersection points, and we draw an arc where it hit the other side of the angle. Keeping the compass at the same setting, we can put a compass at or point at that intersection point and draw an arc. And now we have 2 points that we can connect with a straight line. Okay, so if this was angle ABC, and this was angle DEF, we could say that angle ABC is congruent to angle DEF. And we can also note that with some congruency tick marks, such as that. Okay, so again, we never measured, we created a perfect copy of an angle. 2 more we'll do. One is a perpendicular bisector. This animation is a little bit slower. I'll try to take you through it as we go. So first you want to set your compass so that it's more than half the distance of the line segment. Put the point of the compass on one end of the line and draw arcs above and below the line. It could be one continuous arc if you wanted. Keeping the compass at the same setting, switch the points and draw arcs above and below. And then you're going to be able to connect a line segment connecting those two points of intersection. And that would be a perfect perpendicular bisector. So let me try to sketch that here. So put the point of the compass here and set your compass to a distance that's greater than half the line segment. So I will do something like this. And then we're going to bring the compass over to the other side. It's going to be at the same setting. And we draw a similar arc. Okay. And now we have 2 points to connect. And we can draw that with a straight edge. And what we should have made is a perpendicular bisector. So these 2 halves of the line are congruent. Additionally, the line we drew is perpendicular to the segment we were given. So it's a perpendicular bisector. Our last example is to construct an angle bisector. And this animation goes a little bit quicker, so we'll probably watch it a couple times. First, you're going to start with arc E, this arc that goes through E and D here. Okay. And then you're going to set the point of your compass on point E and point D separately, and then draw those green arcs. Where those green arcs intersect at point F is going to be one point you're going to use, and then you draw a line that goes through the vertex point B. Okay, so let's go ahead and do that. So I'll try to do some color coordinating here so it's the same colors that you're seeing. So first we need an initial point and an initial arc. And the reason you do that, honestly, is because these sides of the angle are drawn to be different lengths, and so we want to create points that are equidistant from the vertex. And then once we have these 2 points that are equidistant from the vertex, we can put our compass here, draw an arc out in the interior of the angle, keeping the compass to the same setting, put the compass here, draw a similar arc out in the interior of the angle. And then once we have those intersecting arcs, we can draw a line through those points, and we have an angle bisector. So let me do some labeling here. So I'll use different letters than what was given in that animation. So we could say that angle ABD is congruent to angle DBC, and we could mark that with our tick marks as well. So we've constructed an angle bisector. We don't know how big the angle is in degrees, and we don't care. All we know is that we've made a perfect, perfectly chopped an angle in half. We sliced it in half. And that is a great place to stop right there.